Your brain is convinced it knows what time is. You feel it slipping away. You feel yourself getting older. You look at a clock and you think you're seeing something fundamental about reality. But that isn't time. That's your brain's interface. It's a biological trick. Most people carry a poetic image. Time is a river. It flows. It carries you from the past into the present and onward into the future. Beautiful metaphor, but it collapses the moment you poke it. If time is a river, how fast does it flow? 1 second per second. That sounds meaningful until you realize it's an empty sentence, like saying a table is 1 table long. It explains nothing. It doesn't tell you what time is. It just restates the measuring system we already built. So let's do something uncomfortable. Let's stop describing how time feels and start describing what time does in physics. Because the confusion begins in your brain. Try a simple experiment. Count to 60 in your head. No timer, just count. 1, 2, 3. Some people count with an inner voice. They're literally speaking silently. And if you interrupt that voice, if you force them to talk, they lose the count. The system jams. Other people count differently. They don't hear numbers. They see structure, a mental tape, a sliding scale, a line of ticks. And because that visual process uses different circuits, they can do something strange. They can keep counting while reading or organizing something else at the same time. That difference matters because it reveals a basic fact. What you experience as the passage of time is not a universal constant. It's a mental construction. It varies across people. It is a pattern recognition routine, not a window into the fabric of the universe. Boredom stretches time. Excitement compresses it. Fear can slow moments into syrup, not because time changed, but because your brain changed the way it samples and stores events. So if we want to talk about physics, we have to throw your internal clock out the window, not because it's useless, but because it's not a measuring instrument. It's an experience generator. Physics does something different. Physics is operational. Instead of asking, what is time in essence, we ask, how do you measure it? And the answer is almost disappointingly simple. Time is a way of ordering events and measuring intervals between them. That's it. A clock is not a time detector. It's a machine that counts a repeating physical process, a pendulum swing, a quartz vibration, a cesium atom oscillation. We define 1 second as a certain number of repeats. Time is not something the clock discovers. Time is the label we assign to change. That's why the most common mistake about time is imagining it as a container, as if the universe is a giant empty box, and time is a clock on the wall ticking even if the box is empty. That view, Newton's absolute time, feels natural, and it's wrong. If absolutely nothing changes, no motion, no vibration, no interactions, then a second has no operational meaning. You cannot define duration without a physical process to mark it. Time is not separate from the universe. Time is part of how we describe the universe. At this point, people object. Okay, but time makes things happen. Time makes me age. Time spoils milk. No, that's language misleading you. Time is not an agent. It doesn't reach into your body and push you toward wrinkles. Biology does that. Chemical reactions do that. Entropy does that. Time is the ruler we use to measure how fast those processes unfold, not the worker causing them. So far, this already breaks the river metaphor. But now comes the part that breaks something deeper, the idea that time is the same everywhere. We used to think a second was a second across the universe. Put one clock on Earth, another on Mars, and in principle, they should tick together. It feels obvious. Relativity says, not even close. The rate at which a clock ticks depends on motion and gravity. This is not a mechanical flaw. It's not that the clock malfunctions, it's that reality is built that way. Move fast, and your clock runs slower compared to someone who stayed behind. Sit deeper in a gravitational field, and your clock runs slower compared to someone higher up. At everyday speeds, you don't notice. You are too slow. The effect is tiny, but it's real, and we rely on it. Satellite navigation systems only work because we correct for relativistic time differences. The universe forces us to do the math, and this brings us to a powerful reframing. Instead of picturing time as something flowing past you, picture it as one dimension of space-time. Your life is a path through a four-dimensional structure. Here's one way to build intuition. You are always moving through space-time. If you're at rest in space, more of that motion points along the time direction. If you move faster through space, the geometry forces less of it to point along time. That's why motion slows your time relative to someone else. Push that idea to the limit. Light. Light travels at the maximum speed allowed in the universe. If you try to imagine light experiencing time, the math says something shocking. Along a light-like path, the proper time interval is 0. In that sense, a photon doesn't age. It doesn't carry a ticking clock through its journey. The emission and absorption are connected by a path with no elapsed proper time. You have to be careful with the language here, because a photon's perspective is not a normal reference frame, but the point is still profound. Time behaves like a geometric quantity, not a universal river. Now notice what just happened. The moment you accept that time is part of geometry, you lose another comforting idea, a universal now. We think the present moment spreads across the universe like a blanket. Right now, something is happening on Mars. Right now, a star is exploding a million light years away. Right now, everything has a shared timestamp. Relativity says there is no single global now. Two events that are simultaneous for you may not be simultaneous for someone moving relative to you. Their slice of space-time, the set of events they label as happening now, tilts compared to yours. Change your motion, and you change your definition of simultaneity. This is not philosophy. It's built into the structure of space-time, and it has been tested. The universe does not come with a master clock. So if there is no universal now, why does time feel like it has a direction? Why do we remember the past but not the future? This is where people think time is doing something special. But again, the more honest answer is, it's not time itself, it's statistics. Most fundamental physics equations don't care which way you run them. Gravity looks fine forward or backward. A planet orbiting a star looks normal either direction, but breaking an egg does not. A smashed egg has countless possible configurations. A whole egg has very few. So when systems interact, it is overwhelmingly more likely to move from a rare ordered state to a common disordered one. That drift is what we call entropy increase. The arrow of time is, in a deep sense, the arrow of entropy. And your brain, this matters, builds memory by leaving physical traces. Memory is not magical. It's a physical process that depends on irreversibility. So the same statistical direction that drives entropy also drives which way information gets recorded. That's why you have a past you can remember and a future you can't. If the universe were in perfect thermal equilibrium, maximum entropy, no gradients, no structure, there would be no meaningful arrow. Nothing would change in a way that builds records. In a universe like that, the difference between past and future would dissolve. Now we reach the strangest layer. If time doesn't flow, if now is not universal, and if the arrow comes from entropy, what is the universe as a whole? One idea is the block universe. If time is a dimension like space, then the past, present, and future are all part of a single four-dimensional structure. Like a film reel, you experience frames in order so it feels like the story is unfolding, but the reel itself already contains the beginning and the end. In that view, the flow is not something the universe does. The flow is how a conscious system experiences its path through the block. And that brings us to the final question, the one that makes your intuition panic. If time is a way of ordering change inside the universe, what happens at the beginning? If we rewind cosmic expansion, we go back to hotter, denser conditions. Eventually, we reach a regime where our current physics breaks down. We don't yet have a complete theory that merges quantum mechanics with gravity. And at that edge, the question appears, what happened before the Big Bang? But now your new definition of time bites you. If time is not an external container, but a property of physical processes, then asking before the universe may be like asking north of the North Pole. The sentence has the right grammar, but the geometry might make it meaningless. There may be no before, because before is a time order concept, and time order might begin with the universe itself. That's not a final answer. It's a warning about the limits of our language. We are biological machines trying to describe a universe that doesn't care about our metaphors. We evolved to track deadlines and seasons, not to intuit space-time geometry. Our brains are efficient, not accurate. And yet, with math, with measurement, with carefully built concepts, we can still see the cracks in our common sense and step through them. So, what is time? It's not a river carrying you. It's not an agent doing things. It's not a universal background clock. Time is the structure we use to order events, measure change, and describe the geometry of space-time. The flow is a story your brain tells to make that structure livable. If that feels unsettling, good. In science, discomfort is often the first sign that your internal translation scheme is failing and reality is starting to show through.